So here is our linear algebra lecture 5. So the first topic is the multiplication of matrix. But you have to remember that here this is a 3 by 3 matrix, because firstly we see the row. So here is 3 row, and then we see the column. So here is 3 column. So our duty is to see, like, we need to find the size of this matrix. So the size of this matrix is 3 by 3 matrix. Oh, this one is row and this one is column, okay? And then the size of this matrix, it is 3 by 1, right? Because we have 3 row here and on column here. Now we need to look at, like, the the column of the first matrix and the row of the second matrix. They needs to be same, okay? You see here, they are same. So if they are same, then only then we can do the multiplication of matrix. Otherwise we cannot use the multiplication, okay? So let me show you how we can do this. So you have to go this way from the first row, and then we have to go this way from the first column. So at first you need to multiply this first entry with this first entry, okay? And then you need to go down from here, and you need to go from right from here, okay? Then we have what? Then we have 0. So 0 so firstly we need to multiply 8 with 1. So 8 multiply 1, then plus 0 multiply minus 2, okay? And then plus minus 1 multiply 3. So this way we write down the first row, okay? So you have to remember that the multiplication, if we multiply a matrix, then the result matrix, there will be a size of ms, okay? ms. So here you can see the size of the result matrix. It will be 3 by 1, okay? The first the row, number of rows from the first column, and then number of columns from the second matrix. Number of row from the first matrix by number of column from the second matrix. So we know that our result matrix will be 3 by 1 matrix, okay? So you can see here, this is the first row, and for the second row we multiply this entry with the first row, with the first first entry here, and then we multiply the second entry with this second entry, and then the third entry with this third entry, okay? And then we write down this way using a plus sign in between them. So this is the result of second row, and for the third row the process is same, okay? So let me show you. So this is our third row, right? So now we multiply this first entry with this first entry, and this one with this one, and this one with this one, and we have to use a plus sign in between them. So this is the result of third row. And then we can calculate 8 multiply 1 is 8 plus 8 plus 0 minus 3, that is going to be 5. And then 2 minus 8 and plus 3, it will be minus 3, and it will be 4, okay? So this way we find the solution of we calculate the we do the multiplication of a matrix, of 2 matrices. Okay guys, can you understand?
Yes.
Okay. So now let's see the transpose of a matrix, okay? Repeat, okay, I see. So Zakira is with us. So we are learning multiplication of a matrix. multiplication of matrix. So we have two matrices here. One is this one and another one is this one. So the first matrix, it is a 3 by 3 matrix, okay? Because we see that we have 1, 2, 3. We have 3 rows here. And also we have 3 columns here. 1, 2, 3. And the second matrix, it is a 3 by 1 matrix because we have 3 rows here. So we firstly calculate the row, okay? And then we calculate the column. So we have 3 rows here and on column here. So that's why this is a 3 by 1 matrix. So for multiplication of matrix, you must remember that the column of the first matrix and the row of the second matrix, they needs to be same, okay? If they are not same, then we cannot do the multiplication. So these two must be same, okay? And then the result matrix will be the number of column, the number of row from the first matrix and the number of column from the second matrix. So the result matrix will be 3 by 1 matrix, okay? 3 by 1 matrix. So now we know that our result will be a 3 by 1 matrix. So the process of this multiplication is you have to go okay. So you have to go from left to right, and you have to go from up to from top to bottom, okay? For the first matrix, you have to go from left to right, and for the second matrix, you have to go from up to down, okay? So see here, we have the first entry 8, and the first entry here is 1. So 8 multiply 1 plus the second entry is 0. So 0 multiply minus 2, that is 0. And then plus minus 1 multiply 3, that is minus 3. So if I calculate here, the result will be 5, okay? 8 multiply 1, 8 plus 0 minus 3. So 8 minus 3, that is 5. And for the second row, there is a 2 multiply 1, 4 multiply minus 2, and on multiply 3. Okay, so I write down it here. And for the third row, minus 3 multiply 1, minus 2 multiply minus 2, and on multiply 3. Okay, so I write down it here. So if I calculate this, I will get the answer 5 minus 3, 4. So you can see that this is a 3 by 1 matrix, because firstly we write down the row, first row, second row, third row. So this is 3 by, we have on column here. So this is a 3 by 1 matrix. Okay. So guys, can you understand? Okay. Faridul, Zakira.
Yeah, brother.
Okay, can you understand this?
Properly.
Okay, fine. So
yes,
yeah, let's continue. So now we will see transpose of a matrix. So we write down transpose this way, like AT. Okay. So if there is a matrix like IJ, so that if there is a matrix like JI, so the transpose will be IJ. Okay. So we change the column and row. Okay, you see here, we change the column and row. So if A is with the size of Mn, then the transpose matrix of A, it has with the size of n gun m. Okay. Okay. So if I have a matrix like 3 by 2 matrix, so transpose matrix will be 2 by 3 matrix. Okay. So let's see a symmetric matrix. A square matrix A is said to be a symmetric matrix if the transpose matrix of A is equal to A. Okay. So if the matrix and the transpose matrix of that matrix is same, then we can say that this is a symmetric matrix. Okay. So here, the transpose matrix of A, it will be similar to the matrix A. For example, this one. So if I write down the row as column, and if I write down the column as row, okay, you see that the result is same. Let me write down here. So this is our first row, right? So I will write down this as a column, as a first column. So 1, 4, 5. And then this is our second row. So I will write down it as a column, like 4, -3, and 0. And last row, I will write down it as a column, right? 5, 0, and 7. So you will see that these two matrix. So this is our. So if this is A, if this first matrix is A, then the second matrix, this will be AT, okay, or the transpose matrix of A. So we can see that all the entries are same, right? All the entries from this matrix and from this matrix, they are same, right? That's why they are symmetric matrix. Okay, guys, can you understand?
Yes, Umar.
Yes.
Okay, Alamin, how are you, brother? Can you understand?
Bro.
Okay, so let's continue.
I just got into it.
Yeah.
I think I will get it. Yeah.
So let's see trace of matrix. If A is a square matrix, then the trace of A, it is denoted as TRA, okay, is defined to be the sum of the entries on the main diagonal of A, of the main diagonal of A. The trace of A is undefined if A is not a square matrix. So for trace matrix, A must be in a square matrix, okay? A must be a square matrix. So let's see here. Oh, there is no example. Okay, so I'll show examples later. Okay. And so let's see how can we write down the matrix form of a linear system. So linear system is like this way, like an equation. Let me show you. So you see here we have a matrix. So we can just say this is the value of x and this is the value of y. That means this column is x, this column is y, and this column is z, okay? Or here this is x1, x2, x3. That means this column is x1, this column is x2, and this column is x3. So we can write down this way, like x1 into 2, okay? That means 2x1, 2x1. And x2 into -3, that means -3x2. And then x3 into 5, that means plus 5x3 is equal to, you can see this is the value, right? So this is the constant. So we can write down this constant on the right side of the equation. That means it will be equal to 7. Okay, as we are working on the first row, that's why 2x1 plus 3x2 plus 5x3, it will be 7. Guys, can you understand? So this way we write down the linear system of a matrix, or we write down a matrix from a linear system. So this is our linear system, okay? Okay. So let's see method of inverting matrix. So elementary matrix 1, 2, 2, 1. So now we will find some kind of we will see how to solve the matrix. Okay. So for example, here we have 1, 2, and 2, 1. So we need to make this matrix as a identity matrix. Okay. Or if you look back in the main diagonal, so main diagonal is this way. So we need to make all the entries below this main diagonal as 0. Okay. Let me change the color. So I mean all the entries below here. Okay. I mean all the entries here. I need to make them as 0. Okay. So and this this line here, this is our main diagonal. This red line, okay, this is our main diagonal. So let's see how can we do this. So to make them these numbers, I mean to make this number and also this number as 0, we can do this operation. So firstly, we need to think that for a identity matrix, all the entries of the main diagonal, it will be 1. Okay. And all the other values, that will be 0. So we need to make some kind of same number on the upside and also on the downside. So firstly, let's make this 2 as 0. So how can we do this? So we can just multiply 2 with the first row. So it will be 2 multiply 1, that means 2, and 2 multiply 2, that is 4. Okay. And then we subtract the first row. We subtract the 2 into first row from the second row. Okay. That means we do this operation like 2 minus 2. Okay. And then 1 minus 4. This is, and then we need to put the value in the second row. Okay, guys. So do you understand why I write down this way?
Yes.
Okay. So that's why 2 minus 2, that is 0. Okay, I am putting the value on the second row because I have written the quotation here. So here it will be 0, and on minus 4, that will be minus 3. Okay, so we got our first 0 here. So we didn't do any change on the first row because look at my quotation. I write down here R2, right? That means I only did the row operation on the second row. That's why our first row is same. Okay, guys, our first row is same as before, 1, 2, 1, 2. Only the second row is changed. Okay, so let's go to the second, the second line. So now we got this one. Okay. Now we need to think of how we can get rid of this this number, right? Because we want this as 1. Because for identity matrix, the main all the entries on the main diagonal, it will be 1. So somehow we got here minus 3, right? That's why we need to get rid of this minus 3. So, and we need to make this as 1. So if I divide minus 3 here, or if I multiply using minus 1 by 3 with the second row, so 0 multiply minus 1 by 3, so it will be 0, right? Anything multiply 0 is 0. So that's why we got 0 here. And then minus 3 multiply minus 1 by 3. So minus minus, it will make plus, and 3 and 3, it will get cancelled, and we will get 1. Okay, so that's why I multiply minus 1 by 3 with the second row. Guys, can you understand? Because we want to make them as an identity matrix. That's why our main diagonal, all the entries on the main diagonal, it needs to be 1. That's why I multiply minus 1 by 3 with the second row. Okay, guys.
Yeah.
Okay. So now let's see how we can make 0 here. So if I multiply 2 with the second row, it will be so 2 multiply 0 is 0, and 2 multiply 1 is 2, right? And then we subtract the second row from the first row. Okay, that means 2 multiply 2, and then we have to put the value, we have to put the result on the first row, because we want this 2 as 0, right? To make identity matrix, we want this 2 as 0. So we need to make this 2 as 0. That's why I multiply 2 with the second row, and then I subtract the second row from the first row. So 1 minus 0, that will be 1, and then 2 minus 2, that will be 0. Okay, so this is our answer. So this way we calculate a matrix, or we find the value of a matrix, or this way we can change a matrix to RREF, or reduce to row echelon form. Okay, this is RREF form. Guys, do you understand?
Yes.
Okay. Alamin, Faridul, Zakira. Okay.
Yeah.
Okay. So let's continue. So there is elementary matrix. Okay, if we can find the identity matrix with just a single operation, okay, by doing only one operation. For example, we can just divide the second row by 3, and then by minus 3, and then we get our identity matrix. So if we can get the identity matrix by doing only one operation, so this matrix here, it will be a elementary matrix. Okay. So this is also another elementary matrix, because we just multiply 3 with the first row, and then R3 plus we perform the same row operation on the matrix A. R3 minus 3 into R1. So I think there will be minus, because if there is minus, and then we have to note this way, like R3. Okay, so I think this will be a minus, because if I multiply the first row with 3, so it will be 3 and 0 and 0, and then I subtract the first row from the third row. Okay, and then I substitute the value to the third row. Okay, I substitute the value in the third row. Then it will be 3 minus 3, that means 0, and then 0 minus 0, that is 0, and 0 okay, sorry, I need to do this way. I mean, I need to subtract, I need to multiply 3 with the first row, and then I need to subtract that first row from the third row. So 3 minus 3, that is 0, and then 0 minus 0, that is also 0, and 1 minus 0, that is 1. Okay, so we got the identity matrix by doing just one operation. That's why this is also a elementary matrix. Okay, so let's continue. So this is also another elementary matrix. We just multiply k with the first row. So it will be k, and then k multiply 0, that will be 0. And then we R2 plus k into R1. I think there will be minus. I don't know how Lao she did this, but there was, I think this should be minus, okay? So it's okay as long as you understand the concept, like how we convert how we can get some elementary, how we can find some elementary matrix. So it will be minus, I think. And then we need to substitute the value to row 2, okay? Because there is our k. So k minus k, that will be 0. So that's why we write down here 0. You see here, Laushi written here, R2 minus k into R1. That means you multiply k with the first row, and then you substitute the first row from the second row. So you subtract the first row from the second row. That means k minus k, that is 0, and on minus 0, that is 1. So this way, doing just on operation, you can convert some matrix to a identity matrix. That's why these are elementary matrix. Okay. So let's see some more examples, some more theory. Equivalence theory. Here Laushi explained so deeply, okay? We don't need to understand all those explanations. Like, we just need to understand the basic theory and also how the operation works, okay? I mean, firstly, Laushi have written down all the formulas and all the explanations, but we don't need to go deep into that, okay? So there is an important formula. Like if we multiply some matrix, for example, here is a matrix with m gun n, m by n size, okay? Here is a matrix A with m by n size. So if we multiply that matrix with identity matrix, so here is a matrix with m by n size, and if we multiply that matrix with a n size identity matrix, then we will get back to that matrix, okay? That means any matrix multiplied with the identity matrix, the result will be the same matrix, okay? So this is a very important formula. Guys, can you understand? A matrix is multiplied with a identity matrix, so we get the A matrix back. There is no change. And there is some way to find the inverse matrix, okay? So now we will see how we can find the inverse matrix. So Lausi explained some basic theory here, but I hope if you do the practice, if I show you the exercise, you can understand how we can find the inverse matrix, okay? Because understanding with this kind of really complex example isn't the right way, okay? So we will understand using some exercise. So let's go to the next note, okay? The next class. So now we will try to find inverse matrix. Okay. A and B square matrix with same size. So then AB is equal to BA is equal to I. So B is the inverse matrix of A. A is the inverse matrix of B. So here I is inverse matrix. That means if I multiply a matrix like this way, A multiply B, and if I also multiply B, if I also do B multiply A, if their result is same, and if their result is identity matrix, then we can say that B is the inverse matrix of A and A is the inverse matrix of B. Okay, so let's see some example. Okay, but before that, there is some condition. Okay, to find inverse matrix, there is some condition. So for any square matrix of A, if A is invertible, then the reduced row S-line form or RREF. So there is some condition. Okay, so the RREF is I to the power n. That means I is inverse matrix. Okay, sorry, I is identity matrix. Here I is identity matrix. So if A is n by n matrix, that means it is a square matrix, right? Because n by n means it can be 3 by 3 matrix or 4 by 4 matrix. Okay, that means this is a square matrix. So number one, A is inversible. Sorry, A is invertible, and AX is 0 has only a trivial solution. That means only on solution. And the RREF of A is I to the power n. And the fourth condition is A is expressible as a product of elementary matrix. So you don't need to understand all this theory. Just try to understand some exercise. Find the sequence of elementary operation that reduce A to identity matrix. Okay, so to do this, so finding inverse matrix. Okay, so you have to find the inverse of an invertible matrix A. So find a sequence of elementary row operation that reduce A to identity matrix, and then perform the same sequence of operation on I to the identity matrix of n. Then we obtain A inverse. Okay, let me show you. So here is the matrix. Okay, and you have to write down the a same number of, I mean, you have to write down a same number of identity matrix on the right side, and then you have to convert this A to an identity matrix, and then the right side will be our inverse matrix. Okay, so I think it is a little bit hard to understand for you, but when I will show you some example, you will get the answer. Okay, so our first target is we have to write down. So here is this matrix is given. Okay, this matrix is given in the question, and we have to write down the corresponding identity matrix on the right side. So if A is a 3 by 3 matrix, then we have to write down a 3 by 3 identity matrix on the right side. Okay, we have to write down 3 by 3 identity matrix on the right side. So this way, and then we have to convert this thing into something like a 3 by 3 identity matrix, and on the right side there will be some numbers, or there will be our inverse matrix. Okay, so let me show you an example here. So this is a matrix A. Now we need this is a 3 by 3 matrix. Okay, so it is given in the question. So now we have to draw some line this way, And we need to write down the corresponding identity matrix here. That means we have to write down a 3 by 3 identity matrix on the right side, okay? So this way. And then we have to convert this matrix to a identity matrix. So that's why we need to do some row operation, okay? The same way we did before. Like we have to make this matrix as a RREF form or as reduced row echelon form. So we have done this operation. So we have only 1 minute left, so we will join again, okay? So we have done this operation and this operation, and ultimately we got we converted our matrix to a identity matrix. And then on the right side here is our inverse matrix, okay? This is our inverse matrix. So on the second meeting we will go step by step, okay? So we are gonna
Okay.
rejoin
Okay.
again.
Hold on.
So this is our inverse